exponential growth functions and models. Exponential functions can model a growth or a decay. Let P be the initial amount or number present at the time t equals 0. Then under certain conditions, the amount present at any time t is modeled by A equals P e raised to the RT, where R is a constant. Now, when R is greater than 0, then this describes a growth. And when R is less than 0 or negative number, then that describes a decay. So again, the general formula for exponential growth or decay is A equals P e raised to the RT, where A is the final amount or the future amount, P is the initial amount, R is your constant or your rate, and T is your time. The growth of bacteria makes it necessary to time date some food products so that they will be sold and consumed before the bacteria count is too high. Suppose for a certain product that the number of bacteria present is given by f of t equals 500 e raised to the 0.1 t, where t is time in days and the value of f of t is in millions. Find the number of bacteria present at each time. So we want to find the bacteria count that is present after 2 days. So all we have to do, the formula is given to us, is just we're going to plug in a 2 in place of t for time and do the math. Now this is something you're going to have to use a scientific calculator or graphing calculator for. So you'll press 500, then press the E key and raise it to the 0.1 times 2 and press enter. And what you should get is approximately 611, and this is in millions. So after 2 days, the bacteria count is approximately 611 million. Well, how much bacteria will be present after a week? So what do you think we'll plug in? So if we plugged in 2 for 2 days, what would we plug in for 1 week? If you said 7, you're absolutely correct. So we're going to plug in a 7 and do the same thing on the calculator. Press 500 e raised to the 0.1 times 7. Press enter, and then it will show you the bacteria count after a week, which is 1,007 million.